Rules are hard to remember if you don't understand why they work. In this video, we'll make sense of the rule for multiplying fractions and see why common teaching methods don't really help students understand how it works. When you multiply 1/2 by 3/4, you're really finding 1/2 of 3/4. Here's 3/4 visually. A whole unit, 1, is divided into 4 equal parts, and we have 3 of them. So 1/2 of 3/4 means we're taking half of that amount. So we need to split the shaded section into 2 equal groups, because the denominator of 1/2 is 2, and take one of them, because the numerator is 1. What do we have now? We have 3 equal pieces shaded. That's our numerator. But what's our denominator? Remember, our 1 whole was the big rectangle. The denominator tells us how many equal-sized parts make up 1 whole. There's 8 equal-sized pieces that make up the 1 whole, and we have 3 of them. So 1/2 times 3/4 equals 3/8. Did you notice that 1 times 3 equals 3 and 2 times 4 equals 8? The rule for multiplying fractions is a shortcut for this whole process. It isn't random or arbitrary. Not convinced? Let's look at another example. 2/3 times 4/5. Again, we're trying to find 2/3 of 4/5. The denominator of 2/3, 3, tells us we need to divide what we have, 4/5, into 3 equal groups. Then the numerator, 2, tells us to take 2 of these groups. We count the overlapping squares to get 8, and the total number of squares to get 15. We can see that 8 is the product of 2 times 4, and 15 is the product of 3 times 5. When students are told to just multiply across, they don't often know why it works. So if they forget the rule, they can't reason their way to find the answer. But when they understand how the rule emerges from how fractions are written and the meaning of multiplication, they can reconstruct it logically, even if they don't remember all the steps. And, more importantly, they start to see that math is really about patterns and reasoning, not just memorizing tricks. Some people use an overlapping rectangle model for multiplying fractions. So for 2/3 times 4/5, they would represent each fraction with separate rectangles, then place one on top of the other. They then count the overlapping squares for the numerator, 8, and the total number of small rectangles for the denominator, 15. While this model does give the same numerical answer, it doesn't help students understand why this process makes sense. Why are we stacking rectangles? Why are we counting the squares that overlap? Without connecting these steps to the meaning of multiplication and fractions, the model just becomes a visual trick, not a conceptual explanation. To truly understand math, we need to see the logic behind rules and the connections between ideas. Multiplication, whether you're working with whole numbers, decimals, or fractions, can be thought of making groups with what you're given. When you multiply by 2, you're making 2 groups of what you have. When you multiply by 1/2, you're making half a group of what you have. By focusing on what multiplication means, we can see that the same reasoning applies across all types of numbers. And when we connect that reasoning to how fractions are written, where the denominator represents how many equal parts make a whole, and the numerator represents how many of those parts we have, it becomes clear why we multiply numerators and denominators when multiplying fractions. We're not memorizing a rule, we're recognizing a pattern and understanding the logic behind it. Are there any other math rules that were never really explained why they work? Let us know in the comments below. And as always, don't forget to subscribe to Science of Teaching Math for more effective teaching strategies, and we'll see you in the next one.